All right. Hi, everybody. Thank you for joining. So we're going to give it about 5 more minutes for everybody to join, and we'll be right back. For those of you filing in just now, we're going to give it another couple minutes before we get started. We're going to start right around 11:05.
Alrighty. Hello, everybody. I hope you're doing well. Welcome to the webinar. So today we're happy to announce that we're introducing for the Initium One Plus, the new Autosampler that is a next generation Autosampler called the Primariz, and it's compatible with the Initium One Plus. And today we're going to go over multiple key benefits of this instrument. So one of those includes that it's much faster to calibrate the Autosampler now. It's about 8 times faster. And also the measurement runtime is about 3 minutes faster per sample. So let's go ahead and jump in to starting with the calibration. So what we're going to do is we're going to go ahead and click to calibrate the instrument. Awesome. So let's go ahead and click to open a calibration utility and initialize the Autosampler. So right away you can see the Autosampler initializing. And one thing I forgot to mention is my name. I'm Christian. I'm the application scientist at RioSense, and I'll be happy to answer any additional questions you have. So here we have the calibration utility that is associated with the Initium One Plus. And let me show you how easy and quick it is to calibrate these positions. So let's go ahead and click calibrate the injection port. And now we're going to, you can see the Autosampler right away move to the port very quickly. So to calibrate this position, all you have to do is, with your hand, move the arm down, and you're going to center it on top of this fixture that I placed on the injection port. So that's all you have to do. Once you place it in the center, and with the needle touching the fixture, all you do is click next, and calibration is done with that position. So in the past, with the older Autosampler, this calibration would take on the order of minutes. So you would have to get it centered. You would click on these arrows shown here, try to get it centered, and then after that, you had to put a strip in there to make sure the C position was calibrated. But now it's an order of magnitude faster. Now for the vial position calibration, it's equally as fast. So we're going to go ahead and click calibrate for the vial position. All you have to do again is move this arm, center the needle, and that's it. Save the current position, and the Autosampler is going to automatically calibrate the said position for you. So the calibration for the vial has to be done for 2 locations, one for this front left, another one for the back right. And for the back right position, it's done the same way. Let me show you again. You move the arm down, center it, close it, save the current position. And it's going to automatically calibrate the C position for you. So it's that quick, that easy to calibrate it. Now for the wash port inside position, all you have to do is take the arm, place it inside the port a little bit, close it, and click save. That's it. And you would do the same thing for the other port position. It's that simple. Now I'm going to skip the next one. Let's go ahead and click on waste port. So here you want to place the needle where it's going to inject the waste after your sample is run. So you're going to place it here in this region between the port and the end of this fixture, and you're going to click yes, and that's it. So this calibration, you can do it in under 5 minutes. And this is compared to about 40 minutes with the calibration with the older Autosampler. So now this is the last position to calibrate the sample depth. All you have to do is push the needle to the bottom of the vial. So you take an empty vial for this, and that's it. So that instructs the Autosampler how deep to go into the vial to pick up your sample. So that's pretty much the process of calibrating the Autosampler. And once you do this, you're all set to run your samples. So let me go ahead and return back to the software. I'm going to cancel this and exit calibration. And at this point, I'll take any questions if there are any halftime questions before I go into actually doing the measurement for the sample that we have here with the Primariz Autosampler. So I have here my colleague Julian. He's a sales manager here at RioSense, and he's going to go ahead and field the questions for me.
So I have one question that just came in. People are asking, is there a software upgrade required to run Primariz?
Yes, that's correct. So it's different software. You install it, and you should be able to run the unit with that.
Okay. So another question here that says, I have an existing Initium One Plus unit. Can that unit be upgraded to use this new Autosampler?
Of course, you can upgrade it. So for that, we would send the unit. We will go ahead and upgrade it for you, and you will have the Autosampler that will be compatible with the instrument.
Cool. I think that's all of the questions we have for now. Should we go ahead and jump into measuring a sample?
Sure. Let's go ahead and do that. So for that, we're going to be measuring a viscosity standard, MGVS. And so for measuring the sample, we need to have best loading practices. So for that, we recommend using a positive displacement pipette. And here we have set it to about 100 microliters. And then another best practice is to make sure you use compressed air to remove any dust from the vials. So we here already have a sample that we loaded already, and we're going to go ahead and measure that sample in the vial. So let's go ahead and create the measurement protocol to get some data on the sample. So another thing I'd like to point out is that we have here the 3 solvent bottles. So these are to clean your solution after you measure the sample in the chip. So we have 3 bottles typically for biologic samples. The first includes your formulation buffer with an aqueous or twin 20 mixture. After that, you have DI water, and then the last one is acetone. So those are the 3 solvents we commonly use for biologic samples. So another thing that I'd like to point out is that in Primariz Autosampler, despite its benefits, it's also, including the benefits that it has, it's also compatible with 96-volt plate and 40-bar rack, just like the old Autosampler. And it's compatible with all the samples and viscosities that the old Autosampler is compatible with. So let's go ahead and initialize this now. Perfect. So what we're going to do now is design the measurement protocol for the sample we have here. So here we have already the protocol selected. I'm going to rely on this recipe. So using recipes on the Initium allows you to easily and quickly select the protocols you want to run for your samples. So here I'm going to select this 90 microliter protocol. And then we have the sample name and the vial location. And all I'm going to do now is select to run the sample. So let's have temperature control off this time. I'm going to select high throughput mode on. And let's go ahead and start this run. So it informed me that the test syringe is over the use count. So we use the instrument a lot in-house here for testing, and that's why we easily exceeded the use count. But recently we introduced a new plunger for the autosampler with a much higher use count than the old one. And that plunger is a lot more consistent with your loaded volumes you're getting into the vials. So right now you can see, you just saw the Initium Primariz autosampler initializing. And then once it's ready to start loading the sample, it's going to go ahead and quickly pick up the sample at a much faster pace than with the old autosampler. We can see it's starting to load the sample. So here we loaded 100 microliters into the vial. So because of that, we're using 90 microliter protocol. And this is the automatic protocol. So what it does is that it chooses a fixed rate for your sample. So you're measuring the sample multiple times with one shear rate to get very high repeatable data. So you also have the option of selecting other recipes we have here pre-installed for you. So they include a level generator, which is a shear rate sweep. So that's an automatic shear rate sweep for your sample. And the nice thing about that is that it runs shear rates that are pretty much encompass the entire pressure range of the chip. So you're always getting the widest shear rate range for your samples measured. I know there's a lot of interest in viscosity versus concentration data. So with that, you can use this same protocol we're running now. You can run this multiple times here with multiple vials for the different concentrations of your sample. And then, load all of your samples here, start the measurements, and then come back after it's all finished. And then you will have the results for plotting versus concentration. And then again, this instrument is fully automatic. The loading, measurements, and cleaning are all performed without any hands-on assistance after you hit run. So now you can see the autosampler is loading the sample into the test syringe. And at this point, if there's any additional questions, I will take more right now. Are there any questions, Julian?
Let me take a look. So it doesn't look like there's any questions at the moment. But yeah, feel free to keep filling those out, and we'll answer those as we go.
Perfect. Thank you, Julian.
Mm-hmm.
So I see looks like there's a question here. Is the Initium, can the Initium measure samples with particles? Well, so yes, the answer is yes. And if you have particles in your solution, if you have a suspension of particles, the max particle size you can introduce into the channel is around 10% the depth of the channel. Now, if your particles are softer in nature, you can have a little bit more larger particles compared to that 10% criteria. And this is a criteria that's not just for this instrument, but it applies to other viscometers and rheometers in the field. So another nice feature of the Initium as well as the VROC 2 is that you have this retrieval capability. So what happens is that after your sample, all of your sample is pushed to the chip to be measured, there's going to be back pressure of your sample back into the test syringe. So the test syringe will retract and take up the sample again. And that allows you to perform an unlimited number of measurements with just one small sample volume. So in this case, with 90 microliters, we can perform unlimited measurements for multiple temperatures, multiple concentrations, multiple shear rates, just with that sample volume. So now we're going to show here the results. So we can see here on the top left is the viscosity versus time for each push of the sample to the chip. So right now it's running a priming segment. It runs multiple steps for priming to gauge the viscosity of the sample. So after it gauges the viscosity of the sample, it knows what fixed rate to select for all the subsequent measurements. So if your sample is higher viscosity, the rate it's going to run will be lower, and if it's low viscosity, it's going to run at the max rate, so you can get the highest quality data each time. So right now we can see that the loaded volume is about 68.9 microliters, so that's very good for this kind of sample. And we're running a viscosity standard that's about 10 centipoi at 25 C. So we're a little bit lower temperature than 25, and we can see the viscosity is just a tad bit higher than 10. Also, this plot here shows you the pressure drop as a function of the sensor position. So as your sample is moving to the chip sensors, it generates this linear pressure drop from which the viscosity is obtained. And we can see here that the pressure drop is very linear. So the more linear the pressure drop, the higher the quality of your data will be. So here we have it's measuring these samples very quickly. So it's only seconds between measurements. We're already at step number 3. And we can see here this viscosity transient curve is very flat. The quality of the data is very good. And here on the bottom right, we can see the viscosity plotted for each of these segments. So we can see that after the priming segment, the viscosity measured is very consistent. And this error bar is the minimum and maximum of these points measured. So it takes these 3 points here, it averages them out and gives you this viscosity for each of these segments. And then of course we have the temperature plotted as well here. So with this instrument we have the Peltier temperature control. So we have a temperature control and for the tray, as well as another one for the chip and syringe. And the nice thing about this is that you can set the temperatures at different values. So you can set your tray at a low temperature for stability purposes. And at the same time, you can have your measurement temperature set separately in the chip. So we can see now we have about 7 measurements already taken with this sample volume. And for this measurement protocol, we have about 11. So we're almost to the end of all these measurements.
So what is the Autosampler doing in the background while we're measuring?
That's a good question. So right now the Autosampler is cleaning. So on this port, it did the outside cleaning of the needle. And right now it's currently doing the inside cleaning of the syringe. So it's passing sample through the port. And at this moment, I think it's clearing a path to pass more air and sample to the chip. So we can see here the sample was pushed out by the air. So this is done automatically at the same time the measurements are taken. So that way there's no waste of time, while you're measuring your samples, having to wait for that to finish. It's done in conjunction with each other. So we can see the syringe. While I was explaining this, it actually retrieved some of the sample because it went to the end. So it's measuring again with the same volume that it used to measure the previous segments. So we can see here on the right, the viscosity for 10 nine segments. And we can see it's pretty consistent between 10.5 and 10.6 centipole. So it just measured the last segment, which looks very good. Data quality is good, and here we have all of your data plotted. So now what you can do to export this data is you go to the data tab here, and you have all of the data you've taken in the past shown here. So this data here is for the MGBS we just measured. And all you have to do is click select, and then you can export it as database or CSV or Excel file. Now the database file is commonly used for Clarity software. This is the RioSense software used for analyzing, reprocessing, and analyzing your data. So you can do a lot of things with Clarity now. We've added a lot of features recently, like the Ross-Minton model fitting, the equation for Arrhenius equation for viscosity versus temperature, also known as Andrade pairing. We also added model fitting for Cross and Kuroya-Suda models, and there's also enhanced injectability analysis. So you can input the shear rate sweep of any of your samples, and it's going to return the calculated injection force. So we've actually compared this to Instron force gauge measurements, and we've seen a good agreement between the measured force between theirs and our technology. And a benefit of our technology is that you're using less than 100 microliters per sample, as opposed to a milliliter of sample with with force gauges. So you can also select your data and view it in graph form again in the future. So here we have the data you can see again at a later time. And then, of course, you can view it in table form as well. So we can see here the data was very good quality. We have the R-squared is very close to 1.9999. The loaded volume was great, and the viscosity was pretty consistent, very consistent actually.
Cool. All right.
Awesome.
I think that's most of what we had to talk about today. I think that we have blocked out until 11:30, so we'll just hang out for another few minutes and see if any questions come in. Yeah, feel free to ask anything, and if not, then we'll head out.
Yeah, thank you guys so much for joining. If you have any additional questions, feel free to reach out to us, or you can reach out to me or Julian here, or my colleague. She's also an application scientist, Dr. Savila Shabanibargi. You can reach out to any one of us. All right, thank you everybody so much. We're going to go ahead and sign out. Really appreciate staying for the webinar, and other questions, great questions you had for us. We'll see you on the next one. Thank you.